Hello, everyone. So, you may notice that I am in a different orientation than normal. That is because we are working on the room, which is why there is some stuff over there in the background. We're actually furnishing the room. The room is completely cleaned out, which is a big step because previously this was cluttered with boxes from when we had moved in, and we're finally actually getting this room together because my sister, as you may know, is coming to stay with us in March, and she will probably be joining me on the stream for a lot. She also plays guitar, so we'll have some um, working together with that. But today I have a lot to talk about. I have my drawing tablet, and we're starting right on the paint screen. So I just wanted to get right into the topic. So today I want to talk about a new, maybe not necessarily completely new in all of its ideas, but new for me at least, style of artificial intelligence. Now, this will still be in the vein of deep learning and neural network, but the structure itself is going to be somewhat dynamic. So, with a normal deep neural network, based off of what I have been doing with the past project with my game, we have some input data, and there's so many inputs, and then it goes through some weights, and all these weights connect things from one layer to the other, and then we have some midpoint layers with a certain amount of nodes, and so on. And then we finally get some output vector of a certain amount of outputs that in the case of my game were either 1 or 0, but in reality these can be any type of output that we want, and the AI will optimize over time using steepest descent on the weights in order to have a neural network that actually provides a better output. So that's the normal structure. And what I want to talk about today is how I plan to change that structure in order to hopefully make a more dynamic and more long-term artificial intelligence. So I'll get to what I mean by that in a second, but I'm calling this a fishbowl neural network. Now, this isn't the official name. Sorry for the pun. If I'm trying to think of a better name for this that may be a little bit less, I guess, childish, but this is just kind of the picture that came in my head. It kind of reminded me of the plum pudding model from atomic structures. So what I'm thinking is, in a neural network. Sorry, I'm fumbling over my words. We have our inputs like this, and they propagate through a somewhat rectangular system. Now they can bounce around a little bit, but eventually they spit out their outputs, and this is all right because we can get a structure that is very optimized for one task. Now, if we start to dip into the realm of artificial general intelligence, then I think that the standard uh, the standard format for deep learning and creating a neural network is somewhat limited. And so today I hope to present a model that is somewhat more dynamic and versatile in terms of using past knowledge in order to perform new tasks. So, what I mean by a fishbowl uh, method is that we're still going to have our normal inputs. All right. So we have our normal inputs here, and they will be being fed into this fishbowl um, type structure. And so what's going to happen is that there will also be some sort of outputs coming out, and what we need to figure out is what's going on in the middle so that we can create the right amount, the right outputs for the given task. So, in a beginning stage, this would look somewhat like a normal deep neural network. So we would get a structure where there are a bunch of nodes that the weights can be attached to, and these nodes can process through the information using weights and spit out an answer that is correct for the given task that we're talking about. So that could be task one. So that's task one. With task one, we're probably going to get a simple neural network. Now, the way that this will be formed is that every generation, it will be a combination of evolutionary propagation as well as steepest descent optimization. So with steepest descent optimization, the weights are slowly made better in order to produce a better output. But the structure itself cannot be changed. And with evolutionary neural networks, the structure itself is changed, and in order to see what structure will create the best output. So what this allows us to do is create nodes and create new connections between nodes, between generations, and then go and test those. But I figured that if there is perhaps a weight that is being used for one thing, and then it gets a random connection to it from another weight, and now that weight is hoping that it will be doing something else. I want the AI to have a chance to optimize those weights a little bit. So what I'm going to be doing is I'm going to call this a cluster in a sense. I guess we could call this somewhat of a cortex if we're talking in terms of brains. But I just figured this would be nice to be called a little cluster of nodes. So I also called it a school of thought, but that was kind of a pun on the fishbowl idea. So what's going to happen is I'm going to set up a class within Python so that there is a data structure for one node. Now this node will have the ability to have connections between itself and further nodes, and through recursive methods, it will be able to propagate along all paths possible in order to get to the output and then spit out an answer. Now, this will be relatively slow just because there's a lot of data to crunch, but I'm sure as I go on, I'll be able to optimize for speed. So with this, the AI will go through and it will create connections between the first few nodes and the inputs, and then those nodes will create connections between other nodes so that they can create a path through this vat of emptiness and eventually get to the output. Now, this also means that in the start, there will be no base connections between the inputs and the outputs. This will be something that will have to be learned fairly early on, but it will be hard because it'll be hard not to learn this, because when there's only a few nodes, the probability of picking an output node as one to propagate to is as one to make a connection to will be pretty high. So I think that shouldn't be a problem. So why I'm drawing it this way as opposed to a normal structure is because there is no real restriction on what connections can be made here. So other than the fact that you can't really go back to the inputs, because that wouldn't make any sense, all of these nodes are they can be added up to. So when you make connections, say that this first guy was connected to this one, and this second guy was connected to this one, and this third guy was connected to this one, all across some weights, then the weights would be applied to the inputs, and then all of those would be added up, and that would be the value of this node. And then this node could be connected to a couple other nodes, and of course having weights between those, and it would multiply its value by those weights, and those would be the values of these nodes here. And so these can go off and propagate through, and eventually we're going to get over to the outputs. Now this would be for a simple task because there is only one cluster. But what I plan to do is set up a system where all of this information about the structure of the cluster and the past learning will be saved so that when I go on to the next project, it's still the same AI with the previous information running and trying to learn this. Now, what this means is I can first set up a task where the AI would perhaps learn to move and take sensory inputs and get to a position. And then I can probably set up something where the AI can perhaps organize something. I don't know. I'm just sort of throwing things out right now. And then maybe a third task would be some combination of the two. So there would be some way of moving that would also organize something. So maybe like herding something around. But I think this is an interesting idea because if I have one task and then I have a new cluster over here, then these inputs can also go into this cluster and spark its intelligence so that it can create new paths to the outputs and create a different output. Now, this will require some specific things. So there has to be some constant that the AI can make basis off. So the things that it will be able to do in any circumstance should be relatively constant. And I could probably add those and just allow it to relearn the previous tasks. But I'm thinking that the model for this is to sort of have like a robot in a sense. So if we have our little robot here, and maybe our robot has some arms and then maybe some it has like little treads, and so it has these methods of doing specific tasks at its disposal, and it can maybe have cameras or whatnot, and it can use these assets in any way that it wants. So these assets would just be the outputs that it's giving out, and then it can take in different information. So it would also have sensors like the camera and perhaps maybe a tactile sensor or some knowledge of its positioning or orientation. And all of these sensory inputs would be put in through this original input. So it's a lot to explain, and I feel like it'll be better when I have an example to show people, but I just want to kind of get this out here. So what's cool about this idea is this cluster or cortex will still be here when it goes on to figure out the next process. So I was thinking about that, and it's similar to how the human brain we learn simple motor functions, and we can combine those motor functions into more complex functions like perhaps running and catching a ball at the same time or playing the guitar and things like that. So if we learn the simple things, we should be able to use those simple things in order to benefit our learning of the more complex tasks, as opposed to attempting to learn a complex task right off the bat. So what this will mean is that the actual middle part will be the same every time. But based off of the information that is being given and the goal that we are setting up, it will take different paths through the nodes that are set up in order to reach an output that it wants. So it's hard to explain the whole thing here, but I hope I'm doing a good job. I'm going to try to start coding this soon, but there's a lot of things that I don't necessarily have all of the tools to accomplish yet. So this is going to be a very long-term project, but I will be keeping you updated on it in the future. There's one last thing I want to explain, and it's a little bit different from the whole topic, but it does tie in. So on this channel, we talk a lot about neural networks. There's a specific neural network called a convolutional neural network. We usually call that a CNN. And so what a convolutional neural network does, it takes in a large amount of information in a one-dimensional array. And so we can just imagine this long string of numbers. And this information can be coming from any source, but in practical in normal practice, in um, everyday use, the main place that we see this is in classifying images. So if you have an image, let's say there's a person and there's maybe a cat over here, and like a building in the background. Um, what this CNN can do is it can take in the information and pick out what parts of that information are specific things. So it can learn what a cat looks like compared to a human, and it can learn what a building looks like, and then it can point those out. So what I'm hoping to be able to do is to set up a convolutional neural network that can scan through the input data, scan through the sensory data, and figure out what kind of sensor that data is coming from. Because as opposed to saying this is a cat, it would be able to say look at a string of binary, or perhaps a string of whatever data we have, and say this data is coming. That's a terrible arrow. Um, this data is coming from a camera, or this data is coming from a I don't know, a what's another sensor, maybe that. So let's just go with the tactile sensor, and then maybe some sort of geographic location, so a compass. And based off of what the convolutional neural network is giving us, because this can be trained previously. It doesn't have to be learning everything every single time, although I have thought about the idea of the convolutional neural network learning as it goes along. So if we had a single unit robot that when we turned it on for the first time, it would begin learning about its own assets, I think that would be a really interesting idea. But it may be necessary to preemptively um, preemptively train this convolutional neural network. Um, but yeah, so this neural network, this convolutional neural network, would learn what the data looks like coming from a compass, or some sort of sensor or a camera, and it would be able to give a notification at the input stage that say, hey, this is what's coming in, and then allow it to before even getting to the neural network, the main overarching neural network. This information would be weighted, which is something that I've talked about in the previous stream. This weight on specific sensory data allows for an AI to emphasize certain assets that are more important for the given task. So it would analyze what information is coming in. So this classification, and also the task at hand, so the goal. And it would use these two informations to pick out the weight necessary to apply to this input data before entering the neural network. This idea of a goal would also decide what path is being used, and within the large structure of data. Um, this is something that I think would be interesting, because it would allow a robot to not necessarily need a driver for a specific sensor. So if we had a camera on the robot and that camera broke, and we decided to just unplug that camera and plug in a new one that's slightly different, odds are the visual information is relatively similar. And what that means is, if the AI is trained on what camera data looks like, then it can just use its previously learned knowledge to assess that data and enact specific responses based off of that data. Now, it may not be completely accurate, but it will be close enough and will be on the right track so that it can optimize for the new asset in order to continue performing well. Um, I think this would be very important in an artificial general intelligence because it would allow for rapid um, relearning of assets. Say something were to break, then um, it, with humans, when we say have a stroke and there's a problem on the brain side, or if we say lose a limb and we get an artificial limb, learning to use that new asset can take a lot of time, but the brain is very capable of doing so because it can then associate the new inputs with new outputs fairly quickly. And so I think this is a way that we can incorporate this into AI is by classifying the input data. So I was thinking that it may be necessary to sort of standardize what kind of inputs coming in. And I was thinking for a robot, it may be easy to just have a bunch of USB ports on it. And then you can plug those USB ports into wherever you want. Um, and it would just notice that there is a new asset available, analyze what that asset is, and then begin making judgment off of that new asset. So I feel like I'm rambling on a little bit, but that is the general idea. So I'm going to give a little bit of an idea of what the structure of the nodes will look like because that's my first step. I am not necessarily versed enough with convolutional neural networks, although I think that TensorFlow may be very applicable in this situation. But um, with with building the actual simple data structure so that it's a bottom up model, we can make something pretty interesting here. So I'm thinking that we're going to have some class that I'll call node probably. Um, and then obviously there's the init data, but within this there will be some it's essentially going to be somewhat of a linked list. And so I've talked about I haven't really talked about linked lists because I don't really use them that often, but I think this is a perfect scenario for it. So what this means is there's going to be all the data necessary in this node that is necessary for completing the task of holding the current value, maybe some some placeholder values for how many times it's gone through that node and things like that. But at the end, there's going to be a path array. So this path will be where what connections are next. So perhaps this is node 1, and we're going to go to node 2, node 5, node 7 after this. And there will be specific weights associated with that. So maybe within this, each index will also have a secondary number with them. That is the weight. And I know I didn't draw the best picture for a 2D array, but just so the path will be telling us where we're going next, and and also what weight is associated with that connection. Now these connections will be randomly created, and also the nodes will be randomly created. So in the beginning there will be no nodes. There will just be the inputs and the outputs, and there will be no connections between those. So what will happen is through an evolutionary process, we will randomly create new nodes, just constantly upping the number on the index, and then keeping the old ones, obviously, and then creating new connections between those nodes. Now, I don't think it's necessary to get rid of nodes. It's possible that it's necessary to get rid of connections, but in terms of getting rid of nodes, I don't think that's really necessary because we can just reuse them for other circumstances. Now, they will be randomly connected to. I'm thinking it might be better So once we have a fairly complex structure, to only be able to connect to the first few nodes in the sequence, but I don't know that that would necessarily be facilitatable in that given circumstance. So I'm still kind of working a lot of things out, but this is the general idea, so that we just have a class for one node, and we know that it will have a total, and then its information will be used to move along to the next few nodes, or possibly that's the end of the road and it doesn't go anywhere. And that information can be propagated through in order to eventually get an output based off of all these weights. Now, each weight will be optimized, but if we get a very large data structure, we don't want to be optimizing every single weight every single time. So I was thinking that, say, let's on like a two-dimensional scale, so we have our outputs over here and we have our inputs over here. Let's say that there's just a bunch of little dots in here, and all of these are nodes. Now, if we tend to go through this path, while we are going along that path, we want to optimize each of these weights as we go along, so that every time we use that path, we are more likely to optimize this. Now, I'm still trying to decide whether I want to optimize as we go along doing that calculation, but that could be very slow. It may be possible to simply just keep track of every time a specific node fires, and then once we, or perhaps every time a specific weight is used, and then when we work that out, we can plug that into a sigmoid function, which, if you haven't seen, that's 1 minus 1 over e to the x, I believe. Don't let me know if I'm wrong on that, but it should make sense if we do things. So if we put a large number in here, then we get a small number here, and it's closer to 1. And if we put a small number here, then a number closer to 0, then we're likely to get a smaller number here, and we get a number that's less as close to 1. So what we can do is we can turn all of these numbers into a probability, and then what that allows us to do is use that probability in order to decide whether a specific node is optimized. So obviously we're going to be optimizing with steepest descent, but this process will be it will only be optimizing the ones that are used a lot. So I think this may battle a little bit with the evolutionary process, because what I'm thinking is that I will create a random population of children, so they will be copies of the total data structure, and they will also be sorry, I'm trying to just make sure all the words are there. So they will be copies of the total data structure, and they will also be slightly different. So we're going to create mutations within those data structures, whether it be creating new nodes, creating new connections, moving connections, something like that. And then with those changes, obviously we can't just right away test to see if it's better, because odds are if we make some random mutation, it's not going to be better. But perhaps the structure itself is better, and if we allow it to optimize a little bit, it will show signs of improving faster than the current rate. So what I'm thinking is that after optimization, each child structure will be allowed to optimize for a couple extra generations before fitness testing. And then once it has optimized to its fruition, if we see that it is going on a path that is improving faster than the current rate that that the current structure is improving, then we will hold on to the new ones as opposed to the old ones. And if we see that nothing is better, we'll just stick with the old model and continue on, because simplicity is at its if nothing it is faster. So it should be the default. So I think that we have sort of gotten everything that I wanted to talk about out onto paper. Obviously, if you have any questions, which I feel like I haven't given the most thorough explanation, and perhaps I've skipped over a couple things that I was planning to talk about, then please leave those in the chat, leave those in the comments, or message me in any way you wish to. One last thing I wanted to mention, the guy that is the CEO and president of Kirko Eyewear. So that's actually I have them right here. It is a brand of computer glasses. So what it means is it's just this amber lens, and what it does is it cuts down light. So when you are looking at a computer screen, your eyes don't fatigue as much. I did a review on these glasses because I got them for Christmas, and the guy that's the CEO actually commented on my YouTube video, just thanking me for the review. But he did bring up a point that I kind of regretted not mentioning in the video, and I wanted to mention that now, and that is these glasses are significantly cheaper than most of the big name brands in terms of computer glasses. I don't know, the one that always comes to my mind is Gunner, but that's more of a gamer glass. So with these, they are more aimed towards the older demographics that are having problems with looking at screens, but at the same time, I use them pretty much every day, if not every other day, just because I kind of don't want to go blind when I'm older. So I know that I'm going to be looking at a computer screen a lot, especially with the new projects and whatnot that I'm working on. So I like the idea of having some protection from constant light entering my eyes, but they are significantly cheaper than most brands out there. So and it's a pretty good product. It's very light, so they are pretty transparent on your face. Not to make any puns, but I just wanted to mention that because I felt bad that I didn't mention that or emphasize that point well enough in the review video a couple months ago. So I'll put a little link into the corner of for that review. He actually put a comment in that video saying that if you used some code, you could get a discount. I didn't really remember that off the top of my head, but okay, so we're going to be transitioning over to the stock market. I need to actually check to see what the vote total is, and I'm going to be switching my mouse out, so you'll hear some noises. Okay, so yeah, I'm a little confused because my TV screen, that is my second screen, is over here, but then it's usually on the other side of my screen. So when I have it in double screen setup, I have to go to the opposite side in order to get to my TV. It's kind of messed up, but um, okay. So I need to go and check the cards on that video in order to see what the votes were. Um, and then we will be updating the stock market. Hold on, let me just pause that. Okay, so we did get some votes, and I think there may be a problem with that because I know I did vote in that. Um, oh, apparently it's acting like I didn't. Okay, so I had a vote in there, and it didn't register once other people started voting for some reason. So I'm going to go off of the one including my vote. So we have our totals. Let me go switch the screen over to the stock market, and we can get down to business. So, oh, that is not the stock market. Sorry about that. That's actually my finances. That's embarrassing. But let me get this set up. Maximize, and then in the corner. There we go. Okay, so now we have it on the screen here. And so you can see that I'm still in the lead. Megan is fairly close, and she actually refinanced what she has in her assets here. Now she still has a balance of about 50,000, so she's keeping half of her original money in the bank. But she wanted to refinance because blue is at a fairly high point right now, and she wanted to make sure that she was taking advantage of that. So I am just trying to get the screen back to the live stream over here to just make sure everything's fine. So we are going to update the stock market, and we should be good to go. So first off, I will just start typing in the percentages. So red. Actually, no, I said that we were going to start with blue this time. So blue gained a percentage of 25% of the votes. Green got a percentage of 50% of the votes. Yellow got a percentage of 25% of the votes. And if you are astute in the realm of mathematics, you will know that red got a 0% of the votes. Now, we are not seeing a significant change in red at the moment because we do not have a market factor. I don't have my calculator in this room, and I don't feel like going to get it, so we're going to be using Siri. Siri, give me a random number between 0 and 50.
The answer is 28.
I hope you heard that. The answer is 28. So that is our market factor. And finally, we have a day that is not below, or it's not better than the average day. It is slightly worse than the average day, which is why we're seeing that yellow and blue are taking a small loss, even though they earned a 25, and red is taking a significant hit. Green is still going up. So we will go check the scoreboard, and you will see that Megan has actually benefited from her investment. So we will now have to sort this chart from largest to smallest, and we see that Megan has now overtaken me for the highest point on the leaderboard. So we are going to just relay these numbers into the historic data. So we have 118, 165, 118, 165, and we have 148, 287, 148, 287. And we will put a 13 here and click update. And you can see that our graph has updated. So we see a slight drop in blue, a slight drop in yellow, a little bit of a spike here in green, but it's not necessarily off of the average. So that may not be a significant change, but we did see the significance of the change because of Megan's large investment in green. So that was a very smart investment. She's close to quadrupling her original investment. So that is pretty good for a stock market competition like this. And we still see this large gap between the people who are constant residents in the household and the people who are guests on the stream. Now, I do hope to get a couple more guests on the stream. I was talking with a guy named Mr. Positive, a YouTuber that I have been following. He actually subscribed to me, and then I checked out his videos, and he's a riot. But he's actually very talented in the realm of MS Paint, so I think he's a perfect fit for coming on the stream. We might get him on to talk. And I also think that there may be a possibility for other types of collaboration other than just having him on the show. So I'm going to be talking to him in the coming few days, but I'll get back to you guys if I figure out anything in terms of him coming on the show. Also, I've talked to a couple other people about possibly talking on the show. I may be following up with them in the near future, but we will be seeing about that. Now, that blong was actually a notification that I have 10% battery, and I've forgotten to plug my computer in. So we will be having to end this stream fairly shortly. It's saying that I have about 8 minutes left of battery while streaming and also on the internet and also on Excel and also on Paint. So there is a lot going on for the computer, and it is not too happy. So, I think we have updated the stock market. You can see what has gone on. Red is a little bit low. Green is uh, green is the only one that went up this week, but red actually did go pretty down. So that is interesting. I could perhaps invest in red, but I think that we're gonna hold out um, on that for now and see what happens in the week to come because there wasn't a significant change this week, so I don't think that is necessary. But if red continues to go down, I may buy in order to attempt to ride the wave back up. So I want to thank you guys for watching. And I hope that I will be able to get some progress on my project I talked about earlier with the fishbowl neural network, so that I can show you guys what I mean, because I feel like a lot of it is fairly abstract, and if I don't have something tangible, it may be hard to convey the message that I'm going for. So I will be talking to you guys hopefully on Saturday. I have a lot going on this weekend, but I think Saturday is open. So we'll plan for a normal stream on Saturday, but until then, goodbye.